Welcome back. Today we are going to learn 4 funny and silly things. They are silly, but they are very useful. Okay? We will see one by one. The first thing we are going to learn is this. Look at this problem. 32 times 41. I want you to give an approximate answer to this problem. You don't need to be too accurate. Approximate is enough. Approximate means 32 times 41 is 10 or 1 million. That's too far off approximation. I want a reasonable approximation. Okay? So, pause the video and look at this problem. We will do it together. Now we have a number 32. What is the nearest multiple of 10 to 32? It's a 30. We will approximate 32 to 30. And what is the approximate multiple of 10 for 41? It's a 40. Now the multiplication is very easy. The rule is the first by the first. That means you just need to multiply the first digits of these two numbers. That is 3 times 4 is a 12. Okay? And you just have to bring the zeros on the right. Okay? This 0 comes here and this 0 comes here. The answer is 1200. So 32 times 41, the approximate answer is 1200. As simple as this. Now pause the video and try to find the approximate answers to these two problems. Okay, let's do it together. 641. Can you approximate it to any multiple of hundreds? Yes, 641 is close to 600. And 82 is close to a multiple of 10, that is 80. So 600 times 80. The rule is first by the first. Okay, here it's a multiplication. 6 times 8 is a 48. And you just have to bring these zeros to the right. So 0, 0 from here, and then there is a 0 that also comes here. You can say 48,000 or you can say 50,000. That's also an approximate answer. It's valid. Now we have 39 times 63. 39 is close to 40 and 63 is close to 60. So the answer is the first by the first. It's a multiplication here. 4 times 6 is a 24. And we have the 0 here, 0 here. You bring them here. It's 2,400. As simple as this. Now the second funny thing I am going to teach you is this. 72 times 83. I want an accurate answer, not approximate answer. Okay? It's actually a multiple choice question for you. I gave you 4 possible answers. Only one of them is correct. Okay? Pause the video and look at the problem and see if you can pick the right one. Let's do it together. The golden rule here is the last by the last. What it means is, when you are multiplying two numbers here, if you multiply the last 2 digits of these numbers, it will be the same as the last digit of the answer. So here 2 times 3 is a 6. And which of the 4 answers here that is ending with a 6? This one. So this should be the answer. As simple as this. Now pause the video and try to find the last digit of these 3 problems. Okay, one of them is an addition, but the rule remains the same. The last by the last. Okay, we will do it together. So 383 times 887 ends in which digit, which number? You just have to multiply 3 and 7. 3 times 7 is a 21. 21 ends in a 1. So this entire problem will end in a 1. Okay, so this is your 1. And 789 plus 987, okay, ends in which number? The same rule, 9 plus 7, okay, we add the last digits of these two numbers. So 9 plus 7 is a 16. 16 is ending in a 6. So this entire addition problem will end in a 6. As simple as this. Wow, we have now 3 numbers to multiply. But it's very easy. First, let us see the multiplication of these two numbers. Okay, 23 times 48. Maybe the answer is a 4-digit number. Okay, we are only interested in the last digit. Okay, so the rule is the last by the last. We multiply 3 and 8. It's a 24. 24 is ending in a 4. So this answer up to this part will end with a 4. And now we have to multiply this number with 63. And we apply the golden rule again. So 4 times 3 will end in a 4 times 3 is a 12. So it ends in a 2. So this entire problem will end in a 2. As simple as this. The next funny thing we are going to learn is a divisibility check with number 11. For example, we have a big number here, 7, 2, 8, 2, 2, 3, 1. Is it divisible by 11 or not? We need to check without actually doing the division. Actually, there is a very funny way to do this. Okay, I'll tell you this. What we do is, we will add up the numbers in the odd positions and then we add the numbers in the even positions and we subtract one from the other and check if the answer is divisible by 11. Beginning from the number on the left, this is the first position. Okay, we add the numbers in the odd positions of first, third, fifth and seventh positions. If you add these 4 numbers, what we get? 7 plus 8 is a 15. 15 plus 2 is a 17. 17 plus 1 is a 18. So odd positions, the sum of the numbers in the odd positions gives us 18. And even positions, okay, so second one, fourth one and sixth one. So 2 plus 2 plus 3 is a 7. Now what we do? We subtract the smaller one from the bigger one. Okay, 18 minus 7 is 11. So 11 is divisible by 11. So this number is divisible by 11. As simple as this. Now pause the video and check if these 3 numbers are divisible by 11 or not. Okay, let's do it together. 3, 4, 7, 6. Okay, what we do? First, we add up the odd positioned numbers. Okay, these two ones. Okay, the sum of numbers in odd positions. 3 plus 7 is a 10. Now, sum of the digits in the even position. So, 4 plus 6. Okay, this is also a 10. So 10 minus 10 is a 0. 0 is divisible by any number other than 0. So definitely 0 is divisible by 11. So this number is divisible by 11. Okay, now this is a big number. Okay, it's very simple. Okay, we add the numbers in the odd positions. Okay, how much is it? It gives us 1 plus 3 plus 6 plus 7. Okay, usually we can say this is a 10 and there is a 7. So this is a 17. And now sum of the digits in the even positions is simply a 0. Okay, so 17 minus 0 is a 17. 17 is not divisible by 11. So this number is not divisible by 11. Okay, now the next one is 3817. Okay, what is the sum of the digits in the odd positions? So 3 plus 1, it's a 4. Okay, what is the sum of the digits in the even position? So it's a 15. So now what we do? We subtract the smaller one from the bigger one. So 15 minus 4 is 11. 11 is divisible by 11. So this number is divisible by 11. As simple as this. The last thing we are going to learn today is called bar numbers. Okay, it's a very funny thing, but it's super duper useful thing. Okay, we will see. Here we have a clock showing time. Pause the video and tell me what is the time this clock is showing. The hours hand is close to 7 and the minutes hand is at 11. So the time is 6:55. Now there is actually an easy way to tell this time right now. Okay, can you guess what it is? We are actually very close to 7 o'clock, right? How many minutes we are away from 7 o'clock? We are only 5 minutes away from 7. So we can say the time is 5 minutes to 7. Okay, do you get it? Now we can use this kind of trick to change big numbers like 9, 8, 7 into small numbers, and we can handle them very easily. Okay, we will see how to do it. Suppose we have a number 19. 19 is close to a multiple of 10. What it is? It's a 20. So it's actually 1 below 20. Okay, so it's 20 minus 1, right? So we can actually write 19 as 2 bar 1. Bar 1 means a negative 1. Okay, this is a funny way of avoiding to use big numbers like 9, 8, 7 and use numbers like 1 and 2, 3 more and more and make our calculations very easy. So we will see how we will make use of these numbers called bar numbers. Let us see some more funny bar numbers. Suppose we have a number 4 bar 2. Okay, what is this number actually? Can you guess? Pause the video. 4 bar 2, this means actually this is 40 minus 2, right? This is actually a 38. Okay, suppose you have a number like say 8 6 bar 1. Can you guess what this is actually? You just have to handle these two digits. Okay, the 8 remains the same. 6 bar 1 means 60 minus 1, it's a 59. Okay, as simple as this. Suppose we have a number 6 bar 3 0. Can you guess what it is? When there is a bar in a digit in the middle of the number, actually you can split the number here after the bar. So this 0 remains unchanged and 6 bar 3 means 60 minus 3, it's a 57. As simple as this. Now pause the video and see if you can change these bar numbers to back to normal numbers. Okay, the hint is you can actually split the number after the bar, something like this, and can handle them separately, each bar number separately. Okay, let's do it together. Now here we have 5, 2, bar 4, 2. Okay, we only need to handle this part. So 5 and 2 remain unchanged. So 5 remains unchanged. 2 bar 4 means 20 minus 4, it's a 16. And then the 2 at the end remains unchanged. Now here 5 bar 1 means 50 minus 1, it's a 49. And 3 bar 2 means 30 minus 2, it's a 28. And here, the funny thing, 3 bar 1, 3 bar 2, 3 bar 3. We can handle these three as separate pairs. Okay, 3 bar 1 means 30 minus 1, it's a 29. 3 bar 2, 30 minus 2, it's a 28. 3 bar 3, it's a 30 minus 3 is a 27. As simple as this. Now let us see a few more funny bar number problems. Suppose we have a number 5 bar 33. We want to change it back to normal number. What is 5 bar 33? This just means this is 500 minus 33. We have seen this kind of problems earlier. How do we do this? This 5 means 5 hundreds, okay? We will use one of the hundreds to subtract a 33. So this 5 becomes a 4 because we gave away 100 to subtract 33. So now 100 minus 33 is, you have the golden rule. You have to apply all from 9 and last from 10 to the bar part. So 9 minus 3 is a 6, 10 minus 3 is a 7. That's all. Now let's try a few more bar number problems. 7 bar 02. Can you try to convert this into a normal number? Pause the video. This is simply 700 minus 2. That means 698. Okay, actually what we do? 7 becomes 6 because we are using 100 to subtract a 2. Okay, 100 minus 2 is a 98. Okay, actually what we are doing here? We are applying the golden rule to the bar part. Okay, all from 9, last from 10. 9 minus 0 is a 9. 10 minus 2 is a 8. There could be bar digits in the middle of a number as well. That's a possibility. For example, we have say 4 bar 23 and a 1. Okay, 4 bar 23 and a 1. How do we do this? We can split the number after the bar. Okay, what is 4 bar 23? This is 400 minus 23. Okay, 4 becomes 3 and we apply the golden rule to 23. We have all from 9. 9 minus 2 is a 7. 10 minus 3 is a 7 and this 1 remains unchanged. So this is 3771. As simple as this. Suppose you have a number 333 bar 22. Pause the video and see if you can change this number back to normal number. Okay, it's very simple. Whatever is the number before the bar, we reduce it by 1. So 333 becomes 332. And then we apply the golden rule to the bar part. Okay, 9 minus 2 is a 7. 10 minus 2 is a 8. As simple as this. Now we will see a couple of miracles of bar numbers. Okay, first one is in subtractions. Okay, suppose we have a subtraction problem. Say 4, 4, 4. minus 286. Okay, how to do this? Actually, when I ask very small children to do this problem, you know how they do it? They don't care big small. Okay, 4 minus 2 is a 2. Then they see this is the bigger one, but they don't care. Okay, 8 minus 4 is 4. And then they say, okay, 6 minus 4 is 2. So they don't care about borrowing, lending money, whatever it is. Okay, actually in this kind of cases, bar numbers can be used beautifully. Okay, we can actually subtract one column at a time without bothering about borrowing or giving 2 from other columns. Okay, we will see how to do it. What is 4 minus 2? Okay, it's a 2, we know. What is 4 minus 8? We know 8 minus 4 is 4, but what about 4 minus 8? Actually, it's a bar 4. Okay, actually this is a bar 4. And what is 4 minus 6? Okay, we know 6 minus 4 is 2, and 4 minus 6 is actually a bar 2. Okay, this is actually a bar 2. Okay, now what you just need to do is you just change this bar number back to normal number. Okay, there are two bar numbers side by side. We can merge them. This is 2 bar 42. You know this is 200 minus 42. Okay, 2 becomes 1, and then all from 9, last from 10 to the bar part. 9 minus 4 is a 5. 10 minus 2 is a 8. As simple as this. Now pause the video and do this subtraction problem using the miraculous bar numbers. Okay, let's do it together. One column at a time. 6 minus 1, this is a 5. This is a positive 5. Now 7 minus 9. How do we do this? It's a bar number. So actually it's 9 minus 7, okay, it's a 2, but we put a bar because we are subtracting 9 from 7, not 7 from 9. Now 6 minus 0 is a 6. Now what is 7 minus 8? Okay, it's a bar 1. And now you just need to change this number back to normal number. Okay, we can split the number after the bar and can handle these two pairs of numbers separately. What is 5 bar 2? 50 minus 2, this is a 48. And then what is 6 bar 1? This is 60 minus 1. It's a 59. As simple as this. Now we will see the second miracle of bar numbers. Okay, this is in base multiplication. For example, we have a multiplication of say 105 times 98. Okay, do you remember the base multiplication? When we learned the base multiplication, we only learned when both the numbers are below 100 or above 100. Now this is a problem where one number is above the base. Okay, what is the base here? It's 100. Okay, one number is above the base and other is below the base. Okay, here we will use the bar numbers to solve the problem. We will do it together. Okay, how to do this? 105 is 5 above the base, above, so we put a plus. Okay, we write it 0, 5 because 2-digit number, because the base has 2 zeros. And now 98 is how much away from the base? It is 2 below the base. So below, so we put a minus and it's a 0, 2. Now the answer is straight away. So you can do, first we have to do the diagonal calculations. 105 minus 2, or you can say 98 plus 5. Either way, it is 103. Okay, and then what do we have? On the right side, we have 5 times 2. It's a 10, but one number is a positive number, other number is a negative number. So this is actually a negative 10 or a bar 10. Okay. Now what we need to do? We just need to convert the answer back to normal number. Okay, how to do this? if you see there is a bar over the 0, actually you don't need to care about bars to a 0 because 0 is neutral, okay? Only you can put a bar on a 1. Now you know, so we just need to split the number here, okay? So, and we can just change this 3 bar 1 into normal number. So, this 1 remains unchanged, the 0 remains unchanged, the 3 bar 1 is 30 minus 1, it's a 29, and then this 0 remains unchanged. So, answer is 10290. That's all. Now pause the video and do this base multiplication by yourself. Now we have two numbers, okay, one above the base, one below the base. So we will be getting a bar number here, okay. 101, this is just 1 above 100. So we write a plus 01. 99 is just below 100, 1 below 100. So we put a minus 01, and first part of the answer is the diagonal side. So 101 minus 1, this is a 100. And what about the second part of the answer? We multiply these two. 1 times 1 is a 1, okay? So but this is a 2-digit number here. So it's a 01, but there is a bar here, okay? So how to do this? How to change this number back to normal number? You can do it in many ways, okay? What we do, we simply reduce the number before the bar, okay, by 1, okay? 100 becomes 99, okay? And then what we do, this bar part we apply all from 9, last from 10, okay? 9 minus 0 is a 9, 10 minus 1 is a 9. So the answer is 9999. As simple as this. There is another way to remove the bar on this number, okay? 0 is neutral, okay? Actually what you can do, you can put only the bar on 1, okay? And then just change this number back to normal number. Okay, whatever is the number before the bar, this is 1,000, you have to reduce it by 1. So 1,000 minus 1 is a 999. And then this one we apply all from 9, last from 10. There is only 1 here, okay? 10 minus 1 is a 9. Okay, or you can say this is 10,000 minus 1 is 9999. You can do it in so many ways. You will get the same answer. So far we have learned how to change a bar number to a normal number. Okay, before we close, we'll learn a little bit about how to change a normal number to a bar number. For example, we have say 19 and I don't want to use 9. Okay, I want to change this part of the number to a bar number. How to do it? 19 is 20 minus 1, so we can write it as 2 bar 1. As simple as that, okay? Now how about 79? Okay, I want to change this part into a bar number. Very easy. 79 is 80 minus 1, so it's 8 bar 1, okay? Suppose we have a number 7, 6, 8, 9 and I want to change the last digit to a bar number. How to do this? We want to change this number into a bar number, okay? Let's take the help of the number before it as well, okay? 89 is 90 minus 1, so it's a 9 bar 1 and this part of the number remains unchanged. 7, 6 remains unchanged. 89 is 9 bar 1. As simple as this. Suppose we have 508 and I don't want to use 8 here. I want to change this part to a bar number. How to do this? Okay, we take the help of one more number before it. Okay, 08. Okay, 8 is actually 10 minus 2. It's like 1 bar 2. Okay, the 5 remains unchanged. So this is 5, 1 bar 2. As simple as this. Suppose you have a number 287. Okay, I want to change both these digits into a bar number. How to do this? pause the video and think about it. This is very easy. Basically, we want to change it to 300 minus something, right? So 3 bar something. Okay, how to get this something? It's very easy. You just apply the golden rule, all from 9, last from 10 to this part. Okay, so 9 minus 8 is a 1, 10 minus 7 is a 3, as simple as this. What we are doing is, suppose we want to change this part to the bar number, we are increasing the number before it by 1, so 2 becomes a 3, and then we apply the golden rule here. That's all. Now pause the video and change these 3 numbers into bar numbers, okay? I mean the underlined parts of each number, you please change them to bar numbers, okay? And the hint is, for the last one, there is a 2-digit number. I want you to change both digits into bar form, okay? Actually, you can assume there is a 0 before it, okay? Try it now. Okay, let's do it together. How do we do this? So this part we want to change it into bar format, okay? Whatever is the number before it, okay? Here we have a 4, we increase this by 1. So 4 becomes a 5 and we apply the golden rule on this part. So 9 minus 7, 2, 10 minus 9, 1. Okay, this part is a bar part. Basically what we are doing, 479 is nothing but 500 minus 21, as simple as this. Same here, okay, this part we want to change it into bar format, okay. There is a number 3 before it, so 3 we add a 1, so 3 becomes a 4, and these 3 digits we make them bar numbers and we apply the golden rule. So all from 9, last from 10. 9 minus 8 is a 1, 9 minus 8 is a 1, and 10 minus 8 is a 2. Very simple. And now here we want to change both numbers, both digits to bar number. Okay, how do we do this? Okay, there is a 0 before it, we know it, okay. We increase this 0 by 1, okay, so 0 becomes a 1 and we apply the golden rule on 77. So 9 minus 7 is a 2, 10 minus 7 is a 3, this is the bar part. Okay, basically what we are doing, 77 is nothing but 100 minus 23, as simple as this. Actually, I can't help but tell you one more miracle of bar numbers. For example, we have a multiplication 29 times 3, okay. So here, suppose we don't want to use this 9. Actually, small children like this very much. Okay, you can change 29 to bar number, okay. It is actually 3 bar 1, okay, times 3. It will be a, now you do the multiplication. So 3 times 3 is a 9, 3 times bar 1 is a bar 3, okay. This is 9 bar 3. You change this to normal number, it's 90 minus 3, it's 87, as simple as this, okay. In one of the next classes, you will have general multiplication where you will learn, you will learn to multiply any number with any number, okay. There also you can actually use the bar numbers whenever is needed. For example, we have, say, 29 times 28. Suppose you want to do this kind of multiplication. Actually, you can change both numbers to bar numbers. Suppose 29, you can write it as 3 bar 1, and then 28, you can make it as 30 minus 2, that's a 3 bar 2, and then you will do the multiplication, okay. Just keep this in mind and use whenever you need it. Bar numbers are so beautiful and miraculous, and they make our life so easy. We will be using the bar numbers in the later parts of the elementary course as well as in the intermediate level course. Have fun with homework problems of bar numbers. That's all for today. Thank you.